All right, another day of computer science lecture. Today was about logical operators and or not. Ranges with gaps, we didn't really mention anything about that. And then branches, sequential branches or multiple branches, as well as nested branches. So we talked about actually some interesting stuff. Order of operations, when you're looking at logical operators included, it goes pretty much, I think it goes pen, PENMDAS, PENMDAS, and then or. So parentheses, exponents, negation, multiplication, division, addition, subtraction, and then and has operational or precedence over or. So that's important to remember. And then that's the way we think about it as like a human. That's the way it works. But the interpreter, when it's taking the Python and turning it into basically, computer, what is it called? Computer language, computer code, what is that called? We've got assembly level language, computer level language, something along those lines. Computer level code, something along those lines. Computer, I don't know, it'll come back to me later. When it's doing an and, if it's an and operation, if the first thing's false, it just doesn't do the rest. It's like if we have an and, what's the first operand? If the first operand's false, you can just stop executing things and just call it an false statement. Same thing for an or. It only continues to check the rest of the statement if the first statement is false. If it's true, then it just stops right there and it's going to say the thing is true, and that's called short circuit. Short circuit something. I'll have to check what it is because it's short circuit. It's an optimization technique in order to save time and computing power when translating the high-level language down to computer language. Let me check what that's called. Short circuit assembly. No, short circuit Boolean evaluation. Short circuit Boolean evaluation. That's what it is. All right, let's check it out. Yep, short circuit Boolean operation. So for logical operators, the operands are true and false, and the outputs are true and false. Or true or false are Booleans. Right, and then we learned about De Morgan's law, where De Morgan's law, from my understanding, is it's the law of how you negate relational operators, how you negate equality operators, how you negate logical, equality, and relational operators. So if it's greater than, the negation of greater than is less than or equal to. Say if it's less than, the negation of less than is greater than or equal to. The negation of less than or equal to is then, of course, greater than. And then if it's the negation of greater than or equal to is less than. The negation of equality is not. Equals is not equals, and vice versa. Equals is not equals, not equals is equals. And then a negation of and is or, and the negation of or is and. Okay? That's everything from class today. I'll talk to you later today when I'm back to study more. Welcome back to computer science. We're going to jump into SciBooks. I went the wrong domain. It was like a sketchy looking site. Yesterday we did some projects, right? We did a caffeine half-life project. We did a car automobile shop like prices for different services, program. Do we do another program? I feel like we did one other one. It wasn't the password one. What would happen? I don't know. Let's just check so I don't waste too much time trying to recall this. Caffeine levels. Maybe that's all we did. And then the automobile service. Simple statistics. What was this one? Right. This is where we just took random numbers, output the average, and then output the product, and then we format it differently. So I think I did that as well yesterday. So I'm gonna jump into doing some more programs because this is due now tomorrow. So let's get to it, and I'll be back to recall what I learned a little bit. All right, guys, we just spent the entire time working on one program, and I didn't even finish it. That's how you know we're getting more advanced in this course, is that I can't finish a program in 5 minutes. This one is basically, it outputs, it's an automobile services again program. It outputs a list of things you can choose from, services. You type in, it prompts for a first service, you type that in, prompts for a second service, you type that in, then it outputs, you chose this service and this service, the total is whatever, this price. And they can also use a dash to ultimately say no service for the first or second or both services. So it's a lot of control structures, a lot of if, elif, and else structures. Actually, just if and elif at this point. But yeah, that's it for now. I'm gonna keep working on this program later today, and then yeah, I'll be back in a bit to start the next session. Welcome back to computer science. I'm gonna just jump in and finish up this automobile program, and then potentially get to another program. So talk to you in a bit. All right, guys, we finished that program, and I made a strategic move to start with lecture 10, even though we had one more project that's due tomorrow, just to interleave it more, space it more. So I'll do the project tomorrow. Should have plenty of time. I took a look at it. It's about musical frequencies. Seems like it'll probably be a 10-minute, maybe 20-minute program, so we should have plenty of time to finish that. We started lecture 10 then, which is about precedence and comparing data types. And so comparing data types is interesting because we can compare with, I believe, logical, relational, and equality operators. We can compare floats, we can compare integers, and we can compare strings. So the book says while you can compare a float using equality and inequality operators, they don't recommend it. They say don't do it because it's bad practice, because floats are not always accurately represented. When comparing strings, for strings to be equal, they need to have the same number of characters, and the corresponding characters need to be the same. For one string to be greater than the other, I believe it looks at first character of both, converts them to ASCII. If they're different, then it compares them. Maybe not even if they're different. I don't know exactly on this. There's a potential where if they're the same, they go to the next character and they compare them. And there's also potential where it's like if one's greater than the other, it's false because they're not the same, right? One's not greater than the other. They are the same, I mean. So a little iffy on that, little gray area, edge case there. For tuples and lists, though, even though we haven't even gone over tuples and lists, we're just jumping into how to compare them. You can use relational operators on these, and this is where I know if you use greater than or less than for tuples or list, it goes to the first item. If the first item's the same, then it will go to the next item. And if they're different, then it will say is one greater than the other, and then it will determine the Boolean outcome. And then dictionaries, same as like strings, same as lists, same as tuples. They need to have the same number of spaces and everything within them. All the items need to be the exact same and in the same order. Okay, so interesting stuff there. When comparing strings, the interpreter of the computer converting the characters into ASCII values. And then we started 10.2. So 10.1 was about comparing data types, and 10.2 is about precedence. And so I actually did learn the correct precedence now. It's because we learned this in class today, but he didn't explain it as well. It wasn't as clear as the book. It is parentheses first, then it is arithmetic operators. So exponents, addition, multiplication, floor division, modulus, negation, not logical not, but negation, addition, subtraction, and then, so parentheses, arithmetic, then relational and equality operators, so par, and then the logical. So not has precedence over and or, and then and has precedence over or. So all right, changing my notes here. List tuples. Okay, and then dictionaries, and then if two things that can't be compared are compared, it will produce a type error, which is a runtime error. So that's everything for today. We are about, we're well into chapter 10 already, or lecture 10, which means probably over a third of the way through lecture 10. And that's what's going to be due by Sunday. So we got plenty of time on that front. What I'm going to do tomorrow is another programming project. And then we've got our exam starting Thursday, which is tomorrow. And also I've got lab tomorrow. So lots to come. I'll talk to you tomorrow. See ya.